In this video, we're going to continue to look at composition of functions. And this time, instead of focusing on like the formula of the function, what we're going to do is look at when functions are defined other ways, like with tables and graphs and things like that, if we can make sense out of what's going on with a composition. All right, so in this first example here, we have a table. And really, it could be two separate tables, understand. Like, so I could have, you know, this is a table, right? X and f of x. And then I could also make a separate table that has these x values with these g values, right? So, so if it helps you, you could draw two different tables if you wanted, but we've just kind of condensed them into the same one here. All right, and so they start asking us these questions, right? And it's the same structure that we saw in our video notes. So we're doing f of g of 2, right? And we start on the inside and we say, okay, do I know what g of 2 is? Right, so what we're saying is when x is 2, what does the function g do to an x value of 2? Well, we can see here that it turns it into 5, right? So this becomes f of 5. Okay, but what does the function f do to the number 5? Right, it takes the number 5 and turns it into 6. Right? So that's f of g of 2 is equal to 6. This diagram here I'm about to draw is a really nice diagram for visualizing how compositions work. And we'll use it a lot in another example in a little bit. But just to show you how it works here, when we're talking about the composition f of g, right? So f of g is what? Well, first you're taking your x values and you're sending them in to g, and then you're sending those into f, right? Because we start with the inside function, right, g, so that's where the x goes first. Then something pops out of that, and then we send whatever pops out into f. And so a nice way to kind of think about a composition of functions in this sense is, we already drew this type of picture when it came to just a regular function. So now it's almost like we're still thinking of the function as a machine, but there's little smaller machines within it that are doing different things. So kind of the diagram here would be, when we evaluated g of 2, we were sending 2 into g, and out came 5. Then we sent 5 into f, and out came 6. So that's just a nice diagram way of looking at it. Okay. Let me hop down to part E here. I'm going to kind of go a little bit out of order. So when it says f of g of 6, right, that's just our different notation for this, right? So what we're doing now is we're saying we're going to start by putting 6 into g, okay? And what happens when 6 goes into g? Well, 6 gets turned into 4, so out pops 4 right here. So down here I replace g of 6 with 4. But now I'm putting that into the function f. So 4 into f, what does that become? 2. So my answer is 2, and in the diagram, out comes 2. So this diagram type thing might help you. So what I think would be a good thing for you to do is try parts B, C, D, and F on your own. So pause the video and do that. And if it helps you, draw a diagram similar to what I did for f of g, but of course it's got to look a little bit different, right? Okay, so after you tried those 4, let's take a look at what we get and make sure we're all kind of getting the same thing. So g of f of 2, okay, so first I'm sending things into f. So by the way, if you had bothered to draw a diagram of this one, it would be this function g of f, where things get sent into f first. It's supposed to be an f. And then they get sent into g. So in this case, we're sending a 2 in to f. Okay, so what does f do to 2? Well, it takes a 2 and it makes it into a 3, right? So this becomes g of 3, right? Because 3 comes out the other side of f. And then what does g do to the number 3? You can see that it takes 3 and turns it into a 6. So that means out of this composition of functions, I should end up with 6. All right, and then we can do some similar work for C, D, and F. At first, the fact that they're using the same function twice might throw you off. But understand, all you got to do is still start with the inside. What does F do to 1? It turns 1 into 2, right? So F of 1 becomes 2. So this F is still there, but instead of this in here, I get 2. And then what does F do to 2? Well, we already know that F takes 2 and turns it into 3. So my answer there is 3. G of 2, same idea here. So this G of 2 becomes 5, right? 2 goes into G and becomes 5. But then I've still got this G out here. So then G of 5, we can see, is 1. And then just remember, this means F of 5, just like that. The table tells me F of 5 is 6. And the table tells me F of 6 is 3. All right, so we're just kind of exploring this idea of compositions in just a different way, where we're not focusing so much on formulas, but we're focusing on what's the input of my function and what's the output. All right, so now let's take a look at example 2, where we're going to kind of do some similar stuff, but with the graph. Okay, so the key with these graphs is to remember, right, when I see something like g of 5, let me just write this down here, g of 5, what does that mean, right? G of 5 is the y value, right, when x equals 5, right? That's what g of 5 means. So as I do this problem and I'm looking at what is g of 5, figuring out what that is. So I'm first of all only paying attention to g. I don't care what's happening with f at this point. And I want to calculate g of 5. Well, when x is equal to 5, we can see that g is 0. So that means g of 5 gets replaced by 0. Now we pay attention to the function f. Okay, when x is equal to 0, y equals 1 on the f function. So this all turns into 1. All right. So with that idea, I really encourage you to pause at this point and give parts B, C, and D a shot. All right, so in part D, you are starting by looking at f, right? Always start on the inside here. So f of 4 is 1, 2, 3, 4. The y value is 5. So I'm going to say g of 5. So that is turning into 5. And then g of 5, well, we already did that, didn't we? It's 0. And then here, what's f of 0? F of 0 is 1. And then what's f of 1? F of 1 is 2. So we're using the function f twice there. And then f of g of negative 5. Okay, so what's g of negative 5? I'm going to go over here and notice that the y value on that function when when x is -5 is -2. So we go f of -2. And then when I go to -2 in the x, I can see that the y is -1. So this is -1. All right, now example 3 here. This one's a bit tougher. What I would say about example 3 is for this one, we really need to draw that diagram that I did on the previous page. So I'm going to go back here a second. Okay, so this diagram right here, I think is essential to figuring this out. So what's happening here is we've got blanks. Okay, so we have 3 different tables. Okay, and the thing about, so we have f, g, and then we have h, but h is g of f of x. Okay, so right above here, let's make that clear. This is g of f of x. Okay, and so we want to fill in the blanks. And honestly, I think this is kind of a fun puzzle. But if you don't find it fun, you might be wondering, why in the world are we doing this? This seems really difficult. Do we really need to be able to do this? And the answer to that is a thorough understanding of compositions of functions is really important when you go into calculus. And so while maybe in a calculus class you'll never encounter a question exactly like this, basically this is working out the muscles that need to, the brain muscles that need to get stronger in the area of composition of functions, right? It's kind of like if you lift weights, it's kind of like a a power clean. Like, do you ever do that exact movement in real life? Do you do that very often? No, but it builds up the muscles that you do need to use on a regular basis. All right, so we're doing g of f of x. So the first thing is, let's get the diagram drawn properly. So this big box is h of x. And then inside of here, we want to say what's going on. Well, because the f is on the inside, I want to draw the f first here. Okay, so the f goes there. And then because g is the second function you're evaluating, it's the outside function, we put that here. All right, so what we're going to do is let's just pick one of these at random to start with. Okay, a lot of times it's easiest to start with any blanks that are in the g of f of x, so the composition of functions section. So let's try to fill in this one here. So we're trying to fill in, what does the composition do to an x value of 3? So in other words, what I need to do is figure out when 3 gets sent in to this big function, what comes out the other side, right? That's what I need to figure out. Okay, so, well, when 3 goes into the big composition of functions, I know that it also is going straight into f, right? So do we know what f does to 3? Well, yes, we do, right? We know that f takes 3 and turns it into 7. So out of this inside part of this function, I know 7's got to get spit out. Well, what happens if I send 7 into g? Well, this tells me that 7 turns into a 1 when it comes out. Well, if that's what happens when you start with 3, if 1 comes out the other side, then that must mean this is an answer of 1. All right, let's try this for 4. Okay, so I'm going to send 4 in. Okay, I want to know what comes out the other side. So 4, well, it's going to get sent into f first of all, and we know that 4 turns into 9 when you send it into f. Do we know what g does to the number 9? Sure we do. It turns it into 2, right? So coming out the other side here has got to be a 2. And so that means that answer is 2. All right, now when they throw blanks in some of these other spots, it actually does get a little bit trickier. Okay, so let's pick out this one. Let's try that one next. So they're asking us what happens when 2 goes into F. Okay, so when 2 goes into F, and you know what? I feel like I need to kind of change this diagram a little bit. Do the same for G here. I just need more space, right? So I'm going to kind of make this rectangle a little bit bigger. There we go. Make that a G. Okay, so we're saying I want to send 2 into F. What comes out the other side of F? Okay, well, the thing that we do know is that if you're sending 2 into F, you're necessarily also sending it into the big function, right? Into H. So do we know what H does to 2? Yes, we do. We know that in the end, it spits out a 0, right? From this table up here. But guess what? If it spits out a 0, then that 0 must have also come from the function g. Okay, so does g have 0 as an output anywhere? Well, yes, right here, right? So we know that 0 is an output of g, so let's ask ourselves, what input must that 0 have come from? Well, it must have come from 10. And so we know that 10 is what must have been sent into G. So what that means is, based on this diagram, it has to be the case that if 2 goes into F, it comes out as 10. So I can confidently put a 10 right here. Okay, let's try another one here. This time, let's do that one. So what are we saying? We're saying we want to put 6 into G and see what comes out. Okay, so now I'm putting a 6 right here, sending it into G and asking what happens, right? What happens? Okay, so, well, if 6 is an input for G, that must have meant it came from F, right? So is 6 one of the outputs for F? You bet it is. It's right here, right? It's this 6 up here. So where did that 6 come from? It must have come from -1. So that means if a 6 popped out the other side of F, we must have had a -1 going in the first place. But guess what? If -1's going into F, -1 also must go into the big function, right? The composition. So do we know what the big composition does to the number -1? Well, we go up and check and say, oh yeah, we do. It turns -1 into 4. And so therefore this question mark here must be the number 4. And so if 4 comes out the side there, and that must mean it must have come from G, we can fill in a 4 right here. All right, so there's one last one here, and you're going to get a chance to really practice this in your homework. So what are we doing? We're saying, okay, if I put a 0 in, what comes out the other side of F? Okay, well, do we know what happens to 0 in the big composition? Well, sure we do. Out comes -1. Okay, well, we also know that that -1 must have come from G, right? So do we know what G does, or excuse me, do we know what input goes with an output of -1 for G? Well, yeah, it must have come from a 5. So that must mean a 5 is on this side and getting sent into G. So that must mean our answer is 5. So that's a tricky type of problem. And it might take a little getting used to. So just understand these are challenging, but the key here is to draw this diagram, and that'll really kind of help you think through it. when you have these more challenging ones where you got to fill in the blank.